Hello everyone, this is Matt Rogers from South Savary Elementary School. Today I'm here to talk to you about Unit 2, Lesson 12. We only completed about half of this lesson today, so I'm only going to go over about half of the activities in the smartboard and the workbook. But our essential question today was, how do I represent two-digit multiplication by two-digit multiplication using area models? So we used some models that we're familiar with from previous multiplication. I'm sure you remember that we've worked through one-digit by one-digit multiplication, one-digit by two-digit multiplication, and one-digit by three-digit multiplication. This is the first time that we're expanding into multi-digit by multi-digit multiplication. So our first activity today, which is what we really got to, was understanding how to complete two-digit multiplication. On this first page, we covered a coin collecting book that holds 24 coins on a page. There are 37 pages in the book. How many coins can the book hold? And the model represents the equation, which is 37 times 24. Before, we've always had area models that had one box of width and multi-boxes of length. So, for instance, we would have 3 tens or 30 up top and 7, but we'd only have maybe 10 represented going down on the y-axis. So, in this case, what we do is we expand it into its more separated, expanded form. So, along the top, we have 37. You have 3 groups of 10. So, 10, 20, 30, plus 7 individual ones. Along the y-axis, or looking down, you break it into 24 into expanded form, so you have 2 tens and then 4 individual ones. And then basically by lining up the top with the side, you would do 10 times 10, you would do 10 times 10, 10 times 10, over and over 6 times, to get 600s. Then, when you look over at the 7 times 10, you would get 70. 7 times 10 gives you 70. When I look at 10 times 4, I would get 40. Again, same thing, 10 times 4, 10 times 4. So right now I have 600s, 2 70s, 3 40s, and then I have a multiplication problem of 7 times 4, which gives me 28. And you can kind of see up in this top area here, we take all of the partial products, 600, 140, 120, and 28, and we add them all up, as we showed down below, which gives us the unique number of 888. In addition to the mapping model or the math board model, we have our area model sketch, which is a quicker method of doing the same type information. So again, I have this 34 times 24. I expand it into 30 and 7, 30 plus 7, and 20 plus 4. And then more or less like coordinate points or coordinate grid, where the points meet, I have 20 and 30, which gives me 600, same partial product. I've got 40 times 30, which gives me 120. I've got 20 times 7, which gives us 140, and I have 4 times 7, which gives me 28. The same partial products, when I add them all up, I still get 888. The last one is just looking at the place values, and so if I look at the problem, and I expand it, I know that I do 20 times 30, which is 10s times 10s. Then I do 10s times 1s. Then I do 1s times 10s, and then 1s times 1s. I get the same partial products as I did before, but it's in a non-area model method. For these three methods, you still should draw a rectangle, whether it's an exact one, such as the map board or the area model sketch, but you should have an area model associated with these three types of multiplication. More or less, number one, describe how each model shows 600s, 14s, 10s, 12 tenths, and 28 ones. They are the three different ways to show the same partial products. every single time I always had 6 hundreds, 14 tens, 12 tens, and 28 ones. That was pretty much as far as we got. In addition to this, we did do a quick quiz that we'll complete tomorrow. When we look at the homework remembering, we are rounding to the nearest place value, so we're underlining the place value we're looking at, circling the next one, and solving the problem there. For number 5 through 8, we're comparing using those numbers. We are drawing a rectangle to represent our area model when doing the multiplication. So for instance, we would have 6, 300, 50, and 8. And don't forget your addition signs. Same thing for the other problem. And then within each area model, you would answer the question. For our additional information needed to solve the problem, we're going to read through. So Rosalina knitted 8 scarves for gifts. She used 38 feet of yarn for each scarf. How much did she spend? You can pretty easily identify what you're missing and then stretch your thinking. How many smaller rectangles are there in the area model that represents 27 by 83? If you draw out this as the area model sketch, you can identify how many you would break it into, which I'm giving you a little hint on right now. So you would then identify again what their dimensions are. If you do expanded form, that shouldn't be too tough. If you have any questions, let me know, and hopefully this was helpful.